The AppNeta by Broadcom team is excited to announce that as of version 18.4, AppNeta supports TCP-based network monitoring. In this video, we'll look at some of the benefits of monitoring with TCP, then we'll demonstrate how to configure TCP monitoring. Let's get started. Security services such as Zscaler and other content inspection proxies play a crucial role in regulating and inspecting network traffic. Often these services restrict the entire network to use specific ports and protocols and may even block ICMP entirely. By moving from ICMP to TCP for monitoring, we can ensure performance monitoring packets more reliably reach the target. And with TCP commonly permitted on port 443 for HTTPS traffic, monitoring with TCP reduces the need for firewall changes to support network monitoring. By monitoring a web server with the same protocol used for most web transactions, TCP monitoring provides more relevant data. And since TCP traffic is affected by multi-path routing technologies, using TCP to monitor network performance from end users to a web server provides a more accurate reflection of end-user experience of the network. As of AppNeta 18.4, the default protocol for single-ended network monitoring is TCP. The option to monitor with ICMP is still available, and dual-ended monitoring continues to use UDP. Performance metrics collected from TCP monitoring include data loss, data jitter, round-trip time, and latency. Monitoring points will still run trace routes using all three protocols. And thanks to another recent enhancement, monitoring points run trace routes with faster parallel execution. TCP monitoring is supported in AppNeta version 18.4 or higher, and monitoring points must be version 16.1 or higher. The Windows native monitoring point does not initially support TCP monitoring, but keep an eye on the AppNeta release notes for updates. Next, let's take a look at how to configure TCP monitoring in AppNeta. To configure TCP monitoring, create a monitoring policy group as usual. In this example, the monitoring point rules include only monitoring points that support TCP monitoring. We'll look at how to handle incompatible monitoring points in a moment. In the Network Preferences section, select the network protocol to use for monitoring. TCP is selected by default unless the dual-ended monitoring option is selected. In the Target and Traceroute Ports section, we have the option to customize the TCP port. By default, the TCP port is 443, which is typical for web transactions. There are a couple changes to note on this page when TCP is selected. The target type field is locked to auto, and the alert profile options are filtered to include only the profiles that monitor metrics supported for TCP. Let's preview the policy. Then save the policy. When the policy is saved, the monitoring points begin monitoring network path performance using TCP. Next, let's look at some considerations when changing the protocol in an existing policy. Here, we have paths where we can see that TCP trace routes reach the target, but ICMP is blocked. When we open one of the paths, we have the TCP trace route, but no other network performance data. When we update the monitoring policy to use TCP, we can expect that monitoring points will begin sending TCP SYN packets for monitoring instead of ICMP echo requests. The network timeline page for a path will only include TCP metric charts, and the charts will include new TCP-based monitoring results as well as any historical ICMP results. The main consideration will be how the policy handles paths from monitoring points that do not support TCP. In this example, the policy group includes monitoring points that are not yet upgraded to 16.1. When we select TCP as the network protocol, we can see from the message that there are incompatible monitoring points in the policy. If we preview the policy, we can see that the incompatible monitoring points will be removed, and the ICMP paths from the monitoring points will move from in policy to out of policy. In our example, we have the advanced data deletion option turned on. This means that these out-of-policy paths will be deleted after 7 days in the out-of-policy state. If we want to maintain historical ICMP data and need more time to address incompatible monitoring points, we could temporarily turn off the advanced data deletion setting. But in this case, ICMP is blocked, so we are not concerned with maintaining historical data from incompatible monitoring points and will leave data deletion turned on. Let's preview the policy. Then save the policy. The path status for the out-of-policy paths changes to failed. No longer matches monitoring policy. When we upgrade the incompatible monitoring points, the out-of-policy paths will be automatically added back to the policy and the monitoring point will start monitoring the target with TCP. Another consideration when switching from ICMP to TCP is the alert profile. If the ICMP policy uses an alert profile that includes voice or capacity metrics, when we switch the protocol to TCP, the alert profile changes to the default profile for data monitoring. If voice metrics are important, since VoIP uses UDP, we'd want to use dual-ended UDP monitoring or single-ended ICMP monitoring. Now that we have policies configured for TCP monitoring, we have a few options for identifying which protocol is used for continuous monitoring on a given path. All paths are now assigned the Network Protocol System tag. Filter the Network Paths page by Network Protocol to find all paths monitored with TCP. Add the Network Protocol column to the table from the columns pick list to see the protocol used for each path. And on the Network Timeline page, the protocol is listed in the Network Path Details side panel. This concludes the demonstration of how to configure TCP monitoring in AppNeta. To keep up to date with enhancements, remember to keep an eye on the AppNeta release notes and subscribe to release announcements for updates. Thanks for watching.